System error zoom. This is a common problem with the Panasonic Lumix ZS19 and 20, and also the TZ27 and TZ30. This problem can show up in two different ways on your camera, and the first problem is actually the source of the second, and that's where dust gets in and around these zoom sleeves on here, and that causes friction inside. When that happens, the zoom motor has to work harder to extend and retract the lens. A lot of times the lens might get stuck, and maybe you've seen a lot of the YouTube videos where it shows you the different ways to bang on your camera to get it loose or blow air inside here. Well, all you're doing is prolonging the inevitable, which is the second problem. You'll need to remove the lens unit from the camera to do this repair. Be sure to watch my first video to see how to tear the camera down to remove the lens unit. I'll put the link to the video in the description. What happens on this second problem is a direct result of the first problem of dust getting inside the lens unit, because that causes friction, and this motor right here, which is the zoom motor, and it extends and retracts the lens unit, it draws more and more current through these two trace lines in here, which supply power to it. And when that happens and the current gets high enough, it will eventually burn the trace lines out inside the plastic, just like a fuse. And you can't see it just by looking at it. So what you have to do is test the continuity on those trace lines with a multimeter. To test the trace lines inside this flat ribbon cable, we'll start by putting a probe on one of the posts on the motor. Then we'll put the other probe on the other end. Now, to figure out which contact we need to go to down here, we'll just follow this trace line all the way up, and we can see that the two trace lines that are on the right on this flat ribbon cable, looking at it from this side, are the two that feed the motor. So if we go to the other side of the flat ribbon cable, that means these two on the left now are the two that go down here to the motor. So we'll test for continuity by putting a probe on one of them, then putting the other probe on the other end on the motor. Now, obviously, if it's good, it's going to read near 0 ohms. If it's bad and burned out, which I suspect this one is, it's going to read infinite. I have my multimeter set on ohms, and when I test it, I can see that 0.2 ohms is the best that I'll get, and that's because of the resistance in the leads on the probes themselves. When I trace this out, I can see that this post right here is the far left contact up here. The next contact in will be this post right here. We'll test this post first. We know that post is the far left contact on the flat ribbon cable. And there's nothing there. It's open. So now we'll test the other side, and that will be the contact that's the second one in. And it's also open. Now, just to be safe, let's go ahead and check the continuity on the motor itself. And we can see there that the motor is good. It showed 18 ohms. So what we need to do now is to figure out how to repair the breaks in the trace lines inside the plastic. Well, fixing it right here in the plastic where it's actually broken is tough to do. What I've been doing is going up here further and exposing the trace lines by scraping the plastic off and then soldering the wire and running it right over to the post. Doing that with both the trace lines. start by taping this flat ribbon cable over out of the way so that we don't damage it. Now I use a utility knife with a razor blade to scrape the plastic off on each trace line. And what I do is I'll offset where I do it at, so that way they're not directly across from each other, and that way the solder won't make a bridge between the two trace lines. Now you can see on this one that I have about a 1/16 of an inch of the trace line exposed, and this is on the inside trace line, the second one in. So you want to make it at least a 1/16. You want to have enough exposed metal so that the solder bonds to it good. I have the second trace line cleaned off now. It's right here. So now I have access to both of them. I've been using these small copper wires for the repair, but you could use any wire. Mainly it just needs to be small enough to fit in that area. First thing you'll want to do with the wires is tin them by putting a little bit of solder on them. Then trim off the excess, because you'll only need just a small amount of exposed wire with solder on it. Then do a rough estimate on the length that you'll need. And then cut a little bit extra just to be safe. And now we'll end up cleaning these ends and tinning them also. And now put a little bit of solder on each of the exposed trace lines. Okay, and we'll double check and make sure where each trace line goes before we solder it. The second one in, which is this one, if you follow that one out, is now on the right side over here, and it comes down and goes to this post. This one, which is the outside trace line, comes down and it's right here on the left of these two, and comes down and goes here. Now we'll solder the wires onto the posts of the motor. Make sure that you get the right wire on the right post though. The wire that's soldered to the trace line that's on the outside will be the post that's on the left. Then you can just tuck the wires down so that they're out of the way. So we'll test the wire that's going to the post of the motor on the left. We'll put the other probe on the end of the flat ribbon cable, and it's the far outside contact connection that is the end of that. Alright, that's good. So now we'll do the other side, and it'll be the second connection point on the end of the flat ribbon cable. And that one's also good. So now we'll also test the continuity across the motor just to make sure that we don't have a dead short. And it reads good. So everything looks good now. That's all there is to it. Now as long as you'd already cleaned out all the dust from inside this lens unit, you can go ahead and put this back in the camera and try it out.